Welcome from my office, actually. Sitting in here doing a little bit of work here. As you can see, No Shave November is coming in quite nice for me. That's when I happen to be recording this video. Working more now with probability going on. We're going to start talking about some specific language that has to deal with probability. First off is sample space. Just simple definition. Sample space is a list of all possible outcomes. So it's the list of all possible outcomes. All right. So when we're doing an activity or we're doing some type of a probability scenario, the sample space is everything that's possible. All right. So everything that's possible. We'll look at an example in a second. Probability model is just another word out of the book I'm reading here. It says probability model is a description of some chance process that consists of two parts: a sample space S and the probability of each outcome. All right, so we're going to develop a probability model here in a second. All right, and then the event. An event is usually described as it's a combination or collection. So it's a combination or collection. It's a just as good enough word. Combination or collection of outcomes. Okay, so these are all parts of the sample space, but they're specific parts of the sample space. So let's say, for example, I'm going to pull up a picture here. All right, so there we have a picture of all ways, all possible combinations of two dice. All right, and if you can see here, let's see if I can make that bigger. There we go. Their dice are red and green. All right, red and green, so that we can see that this 1 and 2 is different than this 2 and 1. And people usually ask, like, how are they actually different? Well, they're different because you can see if I had a red dice right here and I had a green die right here, all right, this is red 2, green 1. Is that different than red 1 and green 2? So I'd actually take the dice and turn them, and I get different outcomes. They look differently. It's two different events. But when I say, like, if I look here at 3 and 3, if I take the red die and the green die and say 3 and 3, can I change those two dice so that it's a different way of getting 3 and 3? So let me say that again. Can I change the dice and have it a different way of showing 3 and 3? And the answer is no. But 4 and 2 would be 4 and 2, and then the other one would be 2 and 4 down here. So it's two different ways to do the same thing. Now, when we're doing this, an event would be, all right, so this is all 36 possible outcomes. All right, so an event would be something like, and here let's go sample space. My sample space in this example that I'm doing here, there are 36 possible outcomes. Now let's say I make an event to be D, and I'm going to define D. So whenever I'm using variables here, I need to define what it is. So D is getting doubles. Okay, so that's a combination or a collection of all my different outcomes. So I could have 1 and 1, I could have 2 and 2, I could have etc., down to 6 and 6. So there are 6 outcomes in D. There are 6 different ways that I can get doubles in D. All right, so then what I want you to fill in your reflection response, the first thing, what is the probability of getting doubles? All right, based off of our definition of probability, number of outcomes of what I'm looking for divided by all possible outcomes. Write it in there as a fraction, but keep taking notes because there could be something more coming up. All right, time for some more language here. Disjoint. Now, if I have two events and the two events are disjoint, all right, so two events are disjoint. Two events are disjoint. if they share no outcomes. If they share no outcomes. So I'm going to do a Venn diagram. For those of you that remember a Venn diagram, we're going to do lots of Venn diagrams when we're talking about probability. And let's say I'm talking about a deck of cards, and I've got this circle here that represents all cards that are hearts. And I've got this here, gotta make sure I stay inside the boundary, and that's all my diamonds, all my cards that are diamonds. Now, if you're not familiar with a deck of cards, don't worry, we'll talk about it quite a bit. All right, but there are 52 total cards in the whole deck. There are 13 hearts and there are 13 diamonds. These two events are disjoint. They're disjoint because you can see they do not, in any way whatsoever, overlap. They have nothing in common with each other. So if two events are disjoint, that means they share no outcomes. Right? So if you have something that's a heart, there's no way that it can be a diamond. All right, now in a deck of cards, then people say, well, what would be overlapping? So let's take it like this. And I'm going to get rid of this 13. And I'm going to get rid of this 13. All right, go back down here. So now if I have this square, and I'm going to change that, let's say those are aces. There are a grand total of 4 aces in a deck. There is one here that's a diamond, and there's one here that's a heart. How about I change that? Change those to blue, so we see that that's what's going on here. So there's one there, and there's one here. There's also one that's a spade and one that's a club. But now, in hearts, there's one that's an ace, and there are 12 other cards. Diamonds, there's an ace, and then there are 12 other cards. So there's an overlap. So hearts and diamonds are mutually exclusive. Ooh, there is another word. Mutually exclusive. Mutually exclusive is another word for disjoint. It's the same exact thing. This is equal to disjoint. They mean the exact same thing, no difference. All right. Now, complement. Complement would be, I hate ever using the word opposite, but the complement is, let's see, a good way of explaining this. In a deck of cards, we'll stick with a deck of cards, complementary events, so complementary events would be hearts and not hearts. All right, complementary events. Now, what makes those complementary is if I take the probability of hearts and the probability of not hearts and add them up. So you think about a deck of cards. Again, if you know a deck of cards, the probability of hearts plus the probability of not hearts is equal to 1. That's just like the one thing and then what it's not. And that's what complementary events are. Now there's a special notation that we really use instead of this. So what I would say is I'd say probability of hearts plus probability of hearts complement, that means not hearts, is equal to 1. How we use this most often would be if I want to find the probability of hearts complement, I would do 1 minus the probability of hearts. All right. That's the complement rule, but that's what the idea is for what complementary events are. Now the addition rule is the last thing here, and I'm kind of running out of space, but it's basically this. If I have 2 events, now we're going to ignore, no, we can do it. We can do it with this. If I do it with the card example again, if I have event, I'll change colors here again. If I have event A and event B, and event A and event B are disjoint. If A and B are disjoint, then the probability of A plus the probability of B is the same as saying the probability of A or B. Right? It's just a language thing. So if you're reading a problem and it talks about or, use the word or, so probably A or B. So if we're talking about deck of cards, probability of a heart or a diamond. So we do probability of heart or diamond. Since we know that these are disjoint, since see they do not overlap, that means that's going to be equal to probability of hearts plus probability of diamonds. And I already said that there's 13 of each, so this is 13 out of 52 plus 13 out of 52, which is equal to 26 out of 52. I'm going to make a special note here now. Anytime we're doing problems and we're doing fractions, please, 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 make sure you use a horizontal fraction bar. If I write 2652 like that, it almost looks like this, and that's going to mean something different later in statistics or in probability, so don't do that. Only use a horizontal fraction bar. It helps to keep your whole process a little bit neater as you're going along. So now I have a Venn diagram here, and I have this event A, which is a triangle, doesn't matter what shape I use. All of this out here, that's outside of A, is a complement. That's a complement rule. So then see between the two things, either A or a complement, that includes everything. So probability of A plus the probability of A complement is 1. So it counts for everything. All right. If I have this, and I have A and B inside my sample space S, I have three things going on. I've got everything that's in A, everything that's in B, and everything that's not in A or B. All right, so if I wanted to talk about all of this that's not in A or B, all that space would be A or B complement. All right, so the A or B complement is everything not in B, not in A. All right, and then if I draw another one here, I'm going to show a different, oh, by the way, this has got another symbol. A union B. Union means or means union. So now if I got two, let's make it 3. We'll make it a square, or sorry, a rectangle. That's a really bad rectangle. And then 2 circles, and we'll call this A, we'll call this B, we'll call this C. This zone here, that is in both A and C, I used some words though, A and C. All right, the symbol is A. It's like an upside down U, but it's called the intersection symbol, and that is intersection. A and C, A intersect C mean the exact same thing. Those are some good, just general acknowledgement of some terms. I'll come back in the next video and talk about what the different rules are, because we already have a rule for or if A and B are disjoint. We're going to actually come up with a rule for or when A and B intersect. We're also going to have a rule for probability of A and C, right there, which is called, this one over here is called the addition rule. And this one that we have that I'll define in the next video is the multiplication rule. That's good for now. Make sure you're filling out that reflection response, and remember, ask me a question relevant to content that we're doing, because I expect you to be thinking about what's going on, processing, and then asking a legitimate cogent question. Cogent. C-O-G-E-N-T. If you don't know what that means, look it up. Put that also in the reflection response, and I'll see you in class.